This is a short recording about the two large earthquakes that happened yesterday on the 10th of November. The magnitude 7.6 down in the Drake Passage and the magnitude 7.4 earthquake which was up in the Philippines. So we'll start with the Philippines. So this is the magnitude 7.4 earthquake here. There were quite a few aftershocks, as you can see here in this little plot. Okay. And if we look at the focal mechanism solution, it looks like this. Remember, you are looking down on something like a beach ball, a hemisphere, and the dark regions are the quadrants which were moving outwards. Okay, so this is consistent with motion like this on this fault plane here. So this top plate moving up and to the right, and the bottom segment moving down and to the left. Or you could have movement on this side, in which case the movement will be up this way and down on this side. But I've put it this way because the subduction zone is sitting here, like this. The Philippine Sea plate is moving up to the north east, like this. So that's consistent with this fault plane here, with the Philippine Sea plate subducting underneath and the overriding Philippines sitting on top of it here. Okay. So if we look at the inversion for motion, you can see it was quite a large rupture surface. That's 80 kilometers long and about 30 or 40 kilometers deep. Okay. And these arrows are the motion of the hanging wall. So that's the upper part of that hemisphere. Okay, so they are moving upwards. So again, it is consistent with the subduction related earthquake. Okay, the dip is 47 degrees, and this is that solution for the rupture surface just plotted on the map. This is all from the USGS. Plotted on the map here is the subduction front here. Here's the trench. So the motion of this top quadrant is like this from that solution. Okay, and if we plot the Philippine Sea plate relative motion, it's like that. Okay, so it's entirely consistent with the subduction zone earthquake, as we would expect to see in the Philippines here, where you're just sitting along the edge of the ring of fire like that. Okay, so I don't really want to say any more about this earthquake. It's a fairly typical subduction earthquake. It doesn't minimize the damage and the effects for people there, but it is a fairly typical kind of event you would expect to see along a subduction zone. So let's move to the Drake Passage, which is down here. You can see it's a long way away from any subduction zones, and it's actually in the middle of a plate. Okay, this is an intraplate earthquake, which are quite unusual. The focal mechanism solution looks like this, so looking straight down again on the top. So these are pretty much vertical planes. So this is a strike slip earthquake, and it could have a motion like this. Remember, the blue quadrants are the dilational quadrants, and the white quadrants are the compressive quadrants, or like this. Okay, and either of those are consistent with this solution. Okay, so let's have a look at a tectonic map. So this is the tectonic map from this paper here, just a background map. The earthquake was approximately here. Okay, so it's south of this subduction zone, where the Antarctic plate is subducting underneath South America, and then the Scotia plate as well. Okay, so it's south of that subduction zone. It's close to, you can see this little dotted line here. This is an extinct spreading ridge, so it's not spreading anymore, but it's quite close to the ridge, and it's quite close to these transform faults. So maybe it's related to the transform faults. So if we have a look at the orientation, one of the fault plane solutions is like this. That's fairly close to that transform fault orientation. So maybe. So this is unusual, okay? It's intraplate. It's not related to active plate tectonics at the moment, although we're relatively close to plate boundaries. So maybe there certainly will be stresses which are transmitted into the interior of the plate, particularly in somewhere where you're quite close to this kind of zone of complexity. One of the interesting things about this particular earthquake, magnitude 7.6, which is large for an intraplate earthquake, earlier in the year there was a magnitude 7.5, so almost identical place, okay, and the focal mechanism solution for that one is basically the same, okay. So I mentioned stress transfer, and when you have ruptures, unless they go all the way through the block, then the stress is going to transfer. And so this seems to be perhaps an example of stress transfer. We had a large earthquake here, which relieves stress, perhaps, let's say, along a segment of this fault here. That then transfers the stress elsewhere, and then that then fails as well. And this is fairly typical. If you saw something like this, this is what's happening, for instance, in the North Anatolian fault. Along the fault line, stress is gradually transferring eastwards as bits of the fault fail. But that's not what's happening here. We don't have a really large fault which is on a tectonic boundary. And let's just zoom in on this little bit of the Drake Passage and see if we can see whether or not it's related to this extinct spreading ridge. So here's the Drake Passage, here's that extinct spreading ridge here, and these are transform faults which offset the ridge, okay. So when this was spreading, you would have ended up with motion like this. This southern plate would have been moving away this way, the northern plate would have been moving up to the northeast. Same thing would have been happening in this little bit of spreading ridge here, like that. So where the transform fault is, you have a relative motion, with this side moving to the north and this side moving to the south, just here in this region of the transform fault. So you would expect to see a motion in that region there, just where that transform fault sits between the two ridge segments. You would expect to see a relative motion with the southern block moving to the northwest and the northern block moving to the southeast. But what we see from the focal mechanism solution is the exact opposite here, okay? And we're down here as well, so we're not within that region. We're down here, and down here you can see that there's no relative motion along that bit of the transform fault associated with any spreading, okay? So remember, this is an extinct spreading ridge anyway, so it's not spreading now. But what I'm suggesting is that the faults that we're seeing here, the earthquake that we're seeing here, it may well sit on this transform fault, because that's a pre-existing weakness, but the motions are nothing to do with the old plate tectonics that we see in the extinct ridges, okay? This is just a pre-existing weakness which is acting as a conduit for the failure that's happening now, which is unrelated to this spreading, okay? So I think there probably will be, in the coming months or years, interesting papers on this fact that they've got two big intraplate earthquakes within, that one was in August, that one's in October, within a couple of months of each other, basically as large as you can really get in this kind of oceanic crust. So it's very interesting. It's a bit of an enigma, but I thought I would at least mention it today. Well, thank you for listening.